So we've done part one of the fundamental theorem of calculus. So let's think about what this means. So if g prime of x is equal to f, that means g is an antiderivative of f, right? Okay, so antiderivatives are not unique. So there's another one. We could call it capital F, but it'd just be different by a constant, right? Okay, so let's just play with this. So if I plug in b, I'm going to get f of b plus c. And if I plug in a, I'll get f of a plus c. Okay, so let's write out what this g of b minus this g of a is. So I'm just going to write these things, f of b plus c minus f of a plus c. So g of b, think back to this original function here. So this would be a to b, remember, because we're putting b in there. And then if we're putting a in, it's a to a. Oh, we know what that is, right? So this side here, right, this left-hand side of the equation gives me a to b of f of t dt. And what does this other side give me? So we see f of b minus f of a. What happens to the c's? They cancel. So I get f of b minus f of a. So what that means is the integral, you take the antiderivative, and so I'm just going to write the notation here. You take the antiderivative, and then you put this little bracket at the end, and that says you plug in b, and then you subtract off plugging in a. And that's what this is saying right here. So the antiderivative is how you take the integral. So let's do these. So I'm going to say let's take the antiderivative of x squared. That's x cubed over 3. Let's take the antiderivative of 5x squared over 2, and then I put the 0 and the 3 here. So when you take the antiderivative, you don't write the integral sign anymore, and you don't write the dx anymore. So now I'm going to plug in the 3. So I get 3 cubed over 3 plus 5 halves times 3 squared. I'm just doing it to make sure you see what I'm doing. And then subtract off, well, you plug in 0 and you just get 0. So this number is the exact area under the curve. So let's do another one here. So take the antiderivative. So think of these two things, meaning take the antiderivative of this, x cubed over 3 plus 3x squared over 2 between 1 and 3. So I'm going to plug in the 3. So I get 27 over 3 plus 3 halves times 9. And then you want to be careful because you want to have subtract plugging in the 1. So 1/3 plus 3 halves, right? So ugly number things are going to be happening, but you're up for it. So let's talk details. So this one here, I would suggest you rewrite the second one. So this second one here, I would rewrite it as the number root 3 times x to the 1/2, because you want to be ready to do the antiderivative. So like e to the x is e to the x, carry the root 3, and then add 1 and times that same number, the reciprocal of that number, and then between 0 and 4. So you put the 4 in. So plus, so here I would get 2 root 3 over 3, 4 to the 3 halves. Now be careful with the 0, because when I plug in 0 into e, I get a 1, right? The second term is 0. So you should know how to fix this. So 2 root 3 over 3. So this is the square root of 4, 2 cubed, which is 8. And then all of that is one term, and then subtract 1. So that's the answer for example 7. Let's think about this one. Oh, antiderivative of secant squared, that's tangent, and you want to keep the t. Remember, you don't write the integral sign or the dt after you've done the antiderivative, and then you plug in 0 and pi over 4. So you always plug in the top number first. So tangent of pi over 4 is 1. Subtract tangent of 0, so there's it is. That's it. This one here, I want to make sure that you're being careful of rewriting this. You're going to see this one a lot, so you want to think of this as 1 to 5, 1/2 times 1 over u du. So this is ln, right? So it's only like antiderivative of x by itself, no power, right? That gives me the ln. So I have ln of u, keep the same letters, put the 1 and the 5, then plug in the 5, and I don't need to write the absolute value bars anymore because it's positive, and you know that ln of 1 is 0, so that would be the answer. Okay, a couple more. So here you would take the antiderivative, so that's 4 to the x over ln of 4 between 0 and 4. I'm sorry, 0 and 2. So that gives me 4 squared over ln of 4 minus 4 to the 0 over ln of 4. So be careful. This is not 0. So I have 16 over ln of 4 minus 1 over ln of 4. So that could simplify to 15 over ln of 4. This one here, you must separate this. So you want to think of this as e to the t times e squared. E squared is just a number, right? So I can carry the e squared along on the outside, then take the antiderivative of e to the t, which is e to the t, and then plug in the 1 and negative 1. So that gives me e squared times, and I'm just going to make the put the number in, e to the 1 minus e to the negative 1, right? And then I could multiply here, so this gives me e cubed, right? Because you add exponents. And if I add exponents here, I get minus e. So this one here, you must separate it. You must do 1 over x squared plus root x over x squared, so that you're ready to take the antiderivative. Okay, so this is not ln. You want to rewrite this as x to the negative 2. And this one here, you want to rewrite it subtracting exponents, right? So that'd give you x to the negative 3/2 dx, and then between 1 and 9. So take the antiderivative, so I'd get x to the negative 1 over negative 1. And remember, you're adding 1 to the integral. You increase the exponent. So I get x to the negative 1/2 over a negative 1/2, right? And then I would go plug in my numbers 1 and 9. So take the time to fix this, right? Don't just go playing with the ugly things. So this is negative 1 over x minus 2 over root x, right? Then it's going to be much easier to deal with the numbers.